Imagine an ordinary morning. You wake up, drink your coffee, then walk out to the garage and plug in your electric car before heading to work. It takes just 15 minutes, enough time to finish reading the newspaper, and your car is fully charged. You drive 500 miles without stopping once. No fear of running out of battery, no worry about the car losing value after a few years. The battery still feels almost new after 15 years of use. Sounds like science fiction? It is not. This is what Tesla is promising to turn into reality, and not just as a promise on paper. For years, people believed traditional lithium-ion batteries were the ceiling of electric vehicle technology. That we were already close to the maximum of what chemistry could do. That the next major leap, if it ever came, would still take another 2 or 3 decades. But things are changing faster than anyone predicted. In early 2025, Tesla quietly rolled out a chain of technical changes that, according to industry analysts, could become the biggest turning point in the history of electric vehicle batteries since the first Model S rolled onto the road in 2012. This is not a small improvement, not a normal optimization. It is a completely different approach to the battery problem, from materials to structure to manufacturing process. And on the other side of the Pacific, BYD, the Chinese giant that has sold more electric vehicles than Tesla for several consecutive quarters, suddenly realized it was facing a rival that was no longer just following behind, but moving ahead with a very different kind of breakthrough. So what makes Tesla's new battery technology so special that the entire industry has to pay attention? Why is BYD, long seen as a dominant force in the global electric vehicle market, feeling pressure from this move? And is this truly the turning point that could change the entire auto industry? Or is this just another case of Elon Musk promising more than engineering can actually deliver? Before we go deeper into the story, if you enjoy detailed analysis videos like this about technology and electric vehicles, do not forget to subscribe to the channel and turn on notifications, because what is about to happen in this industry is something you will not want to miss. Where is the battery world right now, and why does it need a revolution? To understand why Tesla's new technology matters so much, we need to look back at the bigger picture of the electric vehicle battery industry, and honestly, that picture is not entirely beautiful. Electric vehicles have grown dramatically over the past decade. Global sales increased from fewer than 1 million vehicles in 2015 to more than 14 million vehicles in 2023. But behind that growth, there are still stubborn barriers that the industry has not solved. The first problem is driving range. Even though things have improved a lot, most electric vehicles still make consumers worry about range anxiety, the fear of running out of battery on the road. For Americans living in suburbs or rural areas, where daily travel distances can reach several hundred miles and charging stations are still spread thin, this is not a small concern. The second problem is charging time. Even though fast charging technology has improved, charging from 20% to 80% still takes at least 20 to 30 minutes, even with the fastest charging systems. Compared with 5 minutes to refuel a gasoline car, this is still a big gap in the user experience. The third problem, and this is talked about less often but is just as important, is battery degradation over time. An electric vehicle after 8 to 10 years may lose 20 to 30% of its battery capacity. That does not just affect driving range, it also creates anxiety about used car value, an extremely sensitive issue for American customers who are used to gasoline cars holding value fairly well after many years. The fourth problem is cost. The battery accounts for around 30 to 40% of the total cost of an electric vehicle. For electric vehicles to truly compete with gasoline cars in the mid-range price segment under $35,000, the industry needs to cut battery costs to a level that no one has sustainably achieved yet. These are the 4 major problems that hundreds of companies, thousands of scientists, and billions of dollars in investment are trying to solve every single day. And this is exactly why, when Tesla says it has found a new path, the whole world has to listen. But to understand why this matters so much, we need to look at the core of the entire story, what Tesla calls its next-generation battery. Tesla's new battery technology, not just a better battery pack. The term solid-state battery has probably appeared in many videos and articles you have seen before. It sounds familiar, but do not misunderstand it. What Tesla is doing is not exactly the same as what you may have heard in the past. First, we need to understand why traditional lithium-ion batteries, the kind found in almost every electric vehicle today, have limits. In a normal lithium-ion battery cell, lithium ions move through a liquid called an electrolyte to create electric current. That liquid has a problem. It is flammable, it breaks down over time, and it becomes less efficient when temperatures change. This is why electric vehicle batteries perform worse in winter, and it is also why batteries gradually degrade after hundreds of charge and discharge cycles. A solid-state battery replaces that liquid with a solid material, usually ceramic or a special polymer. The theoretical result? Much higher energy density, longer lifespan, greater safety, and better performance across wider temperature ranges. It sounds simple, but for nearly 2 decades, the industry has struggled to make solid-state batteries commercially real. The problem is this: when you charge and discharge a solid-state battery many times, the contact area between the solid electrolyte and the electrode begins to break apart, creating tiny cracks that make the battery lose its ability to conduct electricity over time. Tesla is not the first company to recognize this problem, but it may be the first company to find a way to solve it at industrial scale. According to information from Tesla patents filed in 2024 and 2025, as well as reports from several industry sources, Tesla is using a method called the dry electrode process, combined with a new generation of solid electrolyte material based on sulfide compounds. This not only addresses the durability problem, but also, and this is the most important point, allows production at a significantly lower cost. While most other companies produce solid-state batteries using a wet process that requires expensive and complicated chemical solvents, Tesla's dry process removes that step completely. The result is a production line that is leaner, cheaper, and faster. But here's the interesting part. Tesla did not invent the dry electrode process. It acquired the technology from a small company, Maxwell Technologies, in 2019. And Tesla has spent nearly 6 years turning that lab technology into something that can be mass-produced. So, what is the result of those 6 years? It may sound simple, but this small detail is exactly what could change the entire game. The real breakthrough. 3 numbers that shocked the whole industry. To understand the importance of this new technology, look at the 3 numbers Tesla is aiming for and compare them with today's reality. The first number? 500 watt-hours per kilogram. Energy density, meaning how much energy you can pack into 1 kilogram of battery, is the most important metric in the world of electric vehicle batteries. The best lithium-ion batteries today reach around 250 to 300 watt-hours per kilogram. Tesla's new generation solid-state battery is designed to reach 500 watt-hours per kilogram, almost double. What does that mean in real life? A car with the same battery weight could travel twice as far. Or with the same driving range, the battery pack could be half as heavy, making the vehicle lighter, more efficient, and cheaper to produce. The second number? A full charge in 15 minutes. If Tesla achieves this, it could completely erase the final reason many people still hesitate to switch to electric vehicles. Solid-state batteries allow much faster charging than liquid-based batteries because they do not overheat in the same way. Tesla is aiming for the ability to charge from 10% to 90% in 15 minutes using a 350 kilowatt power source, a standard already available at many Tesla supercharger stations. The third number, a 1 million mile lifespan. This may be the most shocking number of all. A normal lithium-ion battery is designed for around 500 to 1,000 charge and discharge cycles before its capacity drops to 80%. Tesla claims its new generation battery can handle more than 3,000 cycles, equal to more than 1 million miles of driving. This number is not only suitable for personal cars, it opens the door to trucks, buses, and especially robotaxis, where vehicles operate continuously, 24/7. But numbers are not everything. What matters even more is production capability. No matter how good a technology is, it means nothing if it cannot be produced at large scale. Gigafactory and the mass production challenge. This is where Tesla has an advantage that not many people talk about. Manufacturing infrastructure. Tesla is operating Gigafactory Nevada, the largest battery factory in the world by floor area, along with gigafactories in Texas, Berlin, and Shanghai. These factories are not just production sites, they are industrial-scale laboratories where Tesla constantly tests and fine-tunes its processes. The dry electrode process that Tesla is deploying does not require extremely expensive clean rooms or toxic chemical solvents like traditional battery production. That means when Tesla scales up, costs do not increase in a straight line. Instead, they fall along the learning curve. Elon Musk has said many times that the hardest part is not designing the product, but designing the factory that makes the product. And in this case, Tesla has had 6 years to design both at the same time. According to several analyses from industry consultants, if Tesla reaches its cost target of $60 per kilowatt-hour for its new generation solid-state battery, compared with the current $100 to $120 per kilowatt-hour for the best lithium-ion batteries, then the production cost of a Model 3 or Model Y could fall below $30,000 while still remaining profitable. That is the threshold the entire electric vehicle industry is trying to reach. At this point, you may be thinking, why has no one done this before? The answer is, they have tried, and many have failed. Let's be honest about the challenges Tesla is still facing. Challenge number 1. The dry electrode process is still not fully stable at large scale. Tesla has admitted in several quarterly reports that scaling this process from pilot production to mass production has been harder than expected. In 2023, it set a goal to produce 100 gigawatt-hours of new generation batteries by the end of that year. The actual number was much lower. This is not the first time Tesla has missed a deadline. Challenge number 2. Sulfide electrolyte materials have a moisture problem. Sulfide compounds, the type of solid electrolyte material Tesla is believed to be using, are extremely sensitive to moisture. Exposure to normal air can damage them. That requires an ultra-dry manufacturing environment, a requirement that is both expensive and difficult to maintain at industrial scale. Challenge number 3. The dendrite problem has still not been fully solved. This is the oldest technical problem in solid-state batteries. When a battery is charged and discharged again and again, tiny metallic fibers called dendrites can form and pierce through the solid electrolyte layer, causing an internal short circuit and, in the worst case, a fire. Scientists have greatly reduced this problem, but no one has completely solved it yet. Challenge number 4. Low temperatures are still a weakness. Solid-state batteries, even though they are better than liquid-based batteries in many ways, still lose performance in deeply cold temperatures. That matters for consumers in northern U.S. states where winter temperatures can drop below minus 20 degrees Celsius. Challenge number 5. Competition from alternative technologies. While Tesla is pursuing solid-state batteries, other manufacturers are betting on improved lithium iron phosphate batteries, sodium-ion batteries, or even aluminum-air batteries. There is no guarantee that Tesla's chosen path will be the winning one, and this is exactly where the race becomes more intense, because Tesla is not the only company trying to dominate the future. What are BYD, Toyota, and the other giants doing? When talking about BYD, we have to acknowledge an impressive fact. In 2023, for the first time in history, BYD sold more electric vehicles than Tesla. Not just slightly more, but significantly more, with total sales exceeding 1.5 million vehicles in just 1 year. BYD is not just a car maker. It produces its own batteries, specifically lithium iron phosphate batteries under the Blade Battery brand. Blade Battery has solved 2 important problems. Safety, because it does not catch fire like conventional lithium batteries in most situations, and cost, because lithium iron phosphate is much cheaper since it does not use cobalt or nickel. But BYD is not stopping there. In late 2024, it announced that it was developing its own solid-state battery, with a goal of commercialization in 2027. Not only that, it is also investing heavily in ultra-fast charging technology, specifically a 1,000-volt system that allows 400 kilometers of driving range to be charged in just 5 minutes. 1 minute. 5 minutes. That is not a typo. So, who is winning this race? The answer depends on what you are measuring. If we measure by current sales, BYD is winning. If we measure by charging infrastructure, Tesla is winning. The supercharger network is still the largest and most reliable charging network in North America. If we measure by software and artificial intelligence integration, Tesla is clearly winning its autopilot, and full self-driving systems are still leading. If we measure by overall production cost, BYD has the advantage in the mid-range and budget segments. If we measure by future battery technology potential, that is the biggest unknown. Toyota, a surprising name in this race, has invested tens of billions of dollars into solid-state batteries and says it will have a commercial vehicle with solid-state batteries in 2027 to 2028. Toyota has the advantage of manufacturing experience and a global dealer network, but it is often seen as moving more slowly in the electrification transition. Panasonic, Tesla's longtime battery partner, is also racing. It is building a new battery factory in Kansas with the goal of supplying next-generation batteries to Tesla starting in 2026. QuantumScape, a startup backed by Volkswagen, is one of the most closely watched companies in the solid-state battery field. But it is also facing similar scaling challenges. And in South Korea, Samsung SDI and LG Energy Solution, two of the largest battery suppliers in the world, are also developing their own solid-state batteries with supply contracts for many major car makers. This is not a two-horse race. It is a marathon with many participants on a track where the rules are still being rewritten every single day. So in the end, the biggest question remains: is this technology really powerful enough to change the future? If Tesla succeeds, what will the world look like? Let's step into a hypothetical scenario, but not a science fiction one, in the year 2028. Tesla has successfully commercialized its new generation solid-state battery at large scale. Battery costs have dropped to $60 to $70 per kilowatt hour. The base version of the Model 3 costs $27,000 before tax. Driving range reaches 500 miles on a single charge. Charging to 80% takes less than 20 minutes. What happens next? For American consumers, the barrier to switching to electric vehicles almost disappears. The price competes directly with gasoline cars, the driving range completely removes range anxiety, and charging time is no longer a major inconvenience. According to analysis from Bloomberg NEF, if this scenario happens, electric vehicle market share in the United States could exceed 60% by 2030 instead of 25 to 30% as currently forecast. For the oil industry, gasoline and diesel demand from transportation, which currently accounts for around 40% of total global oil demand, would begin to decline at a speed that cannot be reversed. Major oil companies have already noticed this. Many people in the industry predict that peak oil demand, the point when oil demand reaches its maximum, could arrive a decade earlier than previously expected. For the power grid, the explosion of electric vehicles would put enormous pressure on the national grid, especially if millions of vehicles charge at the same time. But it also creates an opportunity. Electric vehicles could act as mobile batteries for the grid, releasing energy back during peak hours through vehicle-to-grid technology. Tesla has tested this feature in Australia and several European markets. For BYD and Chinese competitors, if Tesla leads in solid-state battery technology, Chinese automakers, which currently have an advantage because of low costs, will face new competitive pressure. But do not underestimate their ability to catch up. China is investing around $15 billion per year in battery research and development, a figure that rivals any country in the world. For the labor market, solid-state battery factories may require different skills compared with traditional lithium-ion battery factories. This could create new job opportunities for highly skilled engineers and technicians, but it also creates challenges for current battery workers who need to transition. For robotaxis and autonomous transportation, perhaps the biggest and least discussed impact is on the robotaxi market driverless self-driving cars. Elon Musk has said many times that Tesla's future is not just about selling cars, but about operating autonomous vehicle fleets. With a battery that can last 1 million miles, the robotaxi business model becomes more realistic than ever. One car could operate continuously for many years without needing a battery replacement. We have gone through a long journey from the limits of traditional lithium-ion batteries to Tesla's dry electrode technology, to shocking numbers about energy density and battery lifespan, to the technical challenges still waiting to be solved, and finally to the future that could appear if everything goes according to plan. So what is truly important here? The important thing is not just that Tesla is developing a better battery. The important thing is that if Tesla succeeds, the entire competitive equation in the auto industry will change. Cost, performance, and user experience, the three factors that decide market share, could all shift at the same time, in the same direction, and at a speed no one can accurately predict. BYD understands this, Toyota understands this, Volkswagen understands this. And that is why all of them are pouring billions of dollars into the solid-state battery race, not because they want to, but because they have no choice if they want to survive in the auto industry of the next decade. But let's be honest, the future still has many unknowns. Tesla has promised big things many times and missed deadlines, from the Cybertruck to the new Roadster, from the solar roof to full self-driving. There is no guarantee that its solid-state battery will arrive on schedule, or that costs will fall fast enough to change the game before BYD or Toyota catches up. And the electric vehicle market still depends on many factors beyond the control of any single company. Tariff policy, raw material prices, the speed of charging infrastructure construction, and just as importantly, consumer mindset and habits, which change much more slowly than technology. But one thing is clearer than ever: the race has begun, and no one can turn back now. The question is no longer, will electric vehicles replace gasoline cars? The question now is, who will shape the next generation of batteries? Who will control the core technology of the electric vehicle economy? And consumers like us, people who will have to live with our car buying decisions for the next 10 or 15 years, who should we bet on? That is a question no video can answer definitively, but it is a question all of us should think about. What do you think? Do you believe Tesla will really make its solid-state battery promises come true? Or do you think BYD or another name will reach the finish line first in this race? Leave your thoughts in the comments below. I read every comment and would really love to hear your perspective. If this video was helpful to you, leaving a like is the best way to support the channel and help this content reach more people. And if you have not subscribed yet, this is the perfect time, because the battery revolution story is not over, and we will continue following it together. See you in the next video.